Okey, rasanya jam sudah menunjuk ke angka 10 ya. So I think we can start our session. Ada akan record session kan? Guru setia akan record ya? Right? Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh and good morning. Salam Jumaat, okay, to the speakers and all the attendees for today's webinar. So let's begin our session by reciting Umur Kita Al-Fatihah. Bismillahirrahmanirrahim. Yeah. Amin amin ya rabbal alamin. Welcome to Stay Motivated Weekly Sharing Session with 5-star RG and RIG webinar. Thank you for joining today's webinar, and for your information, this webinar is organized by Renew. So thanks to Renew. I am Wan Marhaini Wan Omar, your moderator for today's webinar. So today, we have two beautiful speakers from Business Datalytics Research Interest Group, UiTM Cawangan Kelantan, Associate Professor Dr. Fairos Wan Yaacob, and Dr. Syerina Azlin Muhammad Nasir. So they will be sharing with us on the topics of understanding predictive analytics, process and its application, and the use of text mining in analyzing unstructured data. So very interesting topic. So we try to go casual, not too heavy, and hope it will benefit everyone here. So before we get started, just a little housekeeping. I would like to remind all the attendees, please mute your microphone during the session. So if you have any questions, you can type it in the chat box. So I will bring them up at the end of the session. Or at the end of the session, you can also ask the question directly to the speakers by unmute your mic. So I hope everyone will enjoy the session. So ladies and gentlemen, let me briefly introduce our first speaker for today's webinar. So our lovely Associate Professor, Dr. Fairos Wan Yaacob. She's a statistician by profession and attached with Department of Statistics, College of Computing, Informatics and Media, Universiti Teknologi Mara, Cawangan Kelantan. And she's also the head of Business and Datalytics Research Interest Group. So she had a basic statistics degree from UiTM, a Master's of Science in Statistics from UKM, and obtained her PhD in Statistics from UiTM. Her research area mainly focused on statistical modeling in dengue disease and road accidents. In addition to a passion in modeling count data, her interest is also in predictive modeling, data mining, and machine learning. So she's also a data analyst certified trainer and machine learning master from RapidMiner. She has published more than 50 articles in various well-known journals, including Q1 and Q2. Without further ado, I would like to welcome our first speaker to deliver her presentation with the title Understanding Predictive Analytics, Process and its Application. Dr. Wan Fairos, the floor is yours.
Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good morning to all. Thank you to our moderator, Dr. Wan Marhaini, and first of all, I would like to thank Renew for the opportunity given to Business Datalytics for this sharing session. So allow me to share my screen. Clear? Can you see my screen? All right. Okay. So today I'm going to talk about understanding predictive analytics, process and its application. So the content outline of my presentation will begin with introduction, the use of predictive analytics, the process, techniques, and an example, and some of the applications of predictive analytics, and a bit on the tips for effective predictive modeling. Now, what is predictive analytics? Now, predictive analytics is actually a mathematical process that use the current and historical data and analytics techniques such as statistical and machine learning models to make prediction about the future outcomes. So the aim or the goal of predictive analytics is actually to transform data into future insights. Now, if you talk about predictive analytics, it is actually one of the categories in data analytics. So it can be viewed as the third level of analytics in a perspective of data analytics, where we can see it begins with actually the descriptive analytics, continued with diagnostics, predictive, and prescriptive. So starting with the basic one, which is descriptive, the descriptive analytics is basically involving the cleaning, relating the data, summarizing, and visualizing the data. So such as if you are own a company, you might want to, you will answer questions like, what is happening to in my business? You might visualize the sales of your product and so on and so forth. Then you can move, if you have this, you can move to diagnostic. You can drill further into data discovery, where you might want to answer questions like, what causing my sales to increase, or what causing my sales to decrease, and many more. So if you have a good basic of this descriptive and diagnostic, you should have some sort of dashboard that would describe what is happening and what is actually what is happening, and why things are happening in your business. So from this, with a good basic of descriptive and diagnostic, you can move further to predictive analytics. In predictive analytics, it is more powerful analytics where you can answer what is going to happen in the future. All right. So, and of course, it is you cannot easily predict what you aim to predict for simply running your data, but you have to really follow, use the correct steps and process in predictive analytics process. So, of course, if you want to begin a predictive model, normally you would begin with you begin with a set of his current and also historical data, where you will collect all the data for analysis, and normally the data scientists will create the algorithms and or any statistical models and train the data, the subsets of the data, and then run the data to generate the predictive model. Okay, and from this process, you might end with multiple predictive models, and you will conclude with the final one which can give you the best accuracy. So assuming that you have applying and implementing this predictive model for a couple of years, what next you need to do is you might want to monitor the performance of your model. So later the process goes to like looking at the discrepancies between the actual values and also the forecasted values based on your predictive model. And if you inspect there's a huge difference between the forecast value and the actual value, you might go back to the data. You might need to incorporate a new sets of attributes, or you might look into the previous assumptions that you are using. Maybe you're using a bit incorrect assumptions, and many more. So you have to reorganize again everything and run again the model to get a better model. So this process might happen many times until you will have a good model. So that is basically a simple summary about the predictive analytics is all about. So why this predictive analytics matters? There's three big reasons and motivation of this predictive analytics. One is the rise of big data. Predictive analytics is often being discussed in the context of big data. We have data, so many data coming from engineering, where we have data from sensors, instruments, connected systems. If we're talking about company, we have transaction data, sales results, customer complaint, and many more. So the increment of this data, the varieties, velocity, and so many, the explode in the data. So businesses can make data-driven decision based on this data set. So that is what predictive analytics is needed these days. The second reason is increasing competition. So business might seek for an edge in bringing their product to be ahead from their competitor. So using the predictive analytics, the company can have a data-driven predictive model to solve several problems like equipment maintenance. They can make accurate forecast for example, to forecast the demand of electricity grid, and many more. And the third reason is the cutting-edge technologies for big data and machine learning. So from predictive analytics, we can actually extract values from these big data sets. So because these days there's a lot of data coming from different types of structure, like structured, unstructured data from equipment log files or images or videos or sensors. It may come from a structure or even unstructured, semi-structured, and many more. So using these predictive analytic tools, it is necessary to extract all this information, meaningful insights from the data. So to describe, we can see there's a lot of applications of this predictive analysis in the use case in many areas like business, banking and finance, retail, telecommunications, credit scoring. One of which we can see, for example, in business for online advertising and marketing, analysts could use users' data. For example, how long would you stay on the website, which sites will you click on, so that from these data you can determine what kind of product, they can determine what kind of product that you will buy. So that is one of the example in business. And you can also use predictive analytics to detect credit card fraud, or to predict the potential customer churn, and many others. So describing the details of the predictive analytics process is actually consists of 5 important stages that analysts or data scientists should follow. So this is like what I would like to share based on what our RIG groups has been doing for a predictive analytics project. So basically, the first step is to define the requirement. These steps is actually almost likely as in the data mining standard process steps, the cross-discipline as the CRISDM steps. So the first step, which is define the requirement, is very important. Before we move to a predictive analytics project, first and foremost is we need to establish the business goal and define the requirement. Here it involves the business experts and the subject matter experts as well. So discussion between the business users, the subject matter experts, the analysts as well, in defining what are the business goal, the business objective, and transform that particular objective and goals into a data mining goals would help an analyst to produce a good predictive analytics model. So taking one example, if for example, for a customer churn data set, if we assuming that you are an owner of a telco company, the business objective is to improve retention. You might want to reduce, the business goal is to reduce the customer churn. So you need to identify what is actually the business goal, the actual business goal. Here, the business expert need to list the most and prioritize what are the goals that they want to fulfill. And then, for example, if this is the business goal to reduce its customer churn, so the data mining goal is to predict who is likely to churn, so that if you could identify this group of potential customer that is likely to churn, we can take a proactive actions to encourage them to stay in with our product. So that is what happened in the first steps, which is define the requirement. This is very, very important before we move to the second and the following steps. So after we have identified the correct goal and objectives, we can now move to the second steps, which is data preparation. So in data preparation, it involved lots of steps, and mostly it require about 7 to 80% of all the process in the predictive analytics project. Normally, it will take like 70 to 80%. So here you are going to explore, you are going to identify all the relevant data, whether it is suitable, are you clear, the clarity of the data, and also the cleanliness. So it involved, for data preparation techniques, several data preparation techniques that is very, very, very important. Okay. So among the preparation techniques that that need to be considered is first, you have to identify the source of the data. So sometimes you might get the data, the relevant data that suit to your business objective and data mining goals that you have set earlier in step 1. It should be consistent and in line with the data, the availability of the data in the company, how maturity, the data maturity of the company would limit the success of your predictive analytics project. Sometimes the company have few or many goals that they want to achieve, but they have limitation in terms of the data sets. The data set is not available, or sometimes it may be available, but it is not in the correct measurement that can be used to analyze and to perform the algorithm. So back to the structure, the source of the data. So if you want to run the analytics project, once you have clear with the data mining goals, you need to identify what are the data that is needed, or that is available to achieve the objective. So the data may come from one source or may come from many sources. If it comes from many sources, different source like from operational system, or maybe it comes from the other sets is from external data, it requires a data integration. So here you need people from database, from IT as well to help you. So to perform a successful predictive analytics project, it is not a standalone of the work of data analysts or statisticians only. So it requires a team of database people, the IT teams, the business user, the subject matter experts, the data engineer, data scientists as well. Later we will discuss on it. So it requires, first of all, if it comes from many sources, you need to integrate the data. Here it is very important because you need to check on any database anomalies, such as redundancies. You might have, if you integrate the data, you might face problems like redundancies or empty and incomplete fields. So those are things like the experts will solve. The experts from database or IT people will help the team to identify and correct all those duplicate data and database anomalies. So once this is settled, you can move to the next steps, which is data understanding. This is also important, where statistician plays important role in this part. Where once you are clear with the data, now you need to identify the types of your data that you are dealing with, whether it is continuous or it is categorical. Are you dealing and which is your target variable? For example, looking at the data mining process, data mining goal just now, you want to predict who is your customer, the potential customer who is likely to churn. So you need to have which target, you need to identify which target that you are going to use to predict your customer, whether the customer is a potential churn customer or she or he is no longer in the using the product as well. So identification of the types of data, the measurement scale, whether it is in the form of continuous, categorical, or it is discrete, and many others, is very important, because different types of data or different types of target would lead to different machine learning classifier, because you cannot use logistic for binary logistic to continuous types of data, because types of target variable, because and if you have a continuous, so vice versa. So it is important to identify the types of target. And then you can move to transformation techniques. Here, once you have clear with the data, you are clear with your target, you are clear with your inputs and all other variables, you can move to transformation. You might look into the attributes information, pay extra attention to the imbalanced data issues. You might face with your target variable that is majority, 80% or 90% belongs to the first group, and the other small portion belongs to the other group. So that is what is means with the imbalanced data. And also pay attention to too many level of values. If you are dealing with one of the attributes is categorical, but you have like 11 or 20 level of values categories. So you might need to, look at it and regroup it or bin your continuous variable, because too many level of value might also affect the performance of your classifier. So another thing that you need to do in these steps for data preparation is deriving the behavioral information. It is also important. Why? Before you move to modeling, you need to look into the characteristics of your attributes. Look at the measures of variations. Inspect on the values on the variance, standard deviation. Check on any strange values, the minimum or the maximum value. If it gives you a high variance value and standard deviation, there must be something wrong with the attribute. So any deviation from the means, like look at the measures of the trend, do data exploration, produce your histogram, the charts, and many others. And also do data quality checking, generate the summary statistics. And here you need, once you identify if there's any missing value, treat the missing value, any outliers or any illogical values. So once the data is clean, you can also now look into whether are you going to use all the attributes or only the relevant attributes for your model. So it involves data reduction or any feature extraction techniques. So at this stage, once you have clear with this, you can move to the model development, where in model development, you will create the model using any machine learning classifier, depending on your target variables, whether it is continuous or it is target, and you may experiment with different features or algorithms, and you will strike the best models that balance between the performance, accuracies, and other requirements as well. Then the fourth steps is model deployment. Once you have created the model, you have come up with a predictive model, you can now deploy the model, where you put the model into the productions and analyze the performance. And finally is you need to also validate the model results and monitor changes, as what I've been explaining in the previous slides before. Look at the performance, look at the how well is your model performed. So here, every role of data scientist lies in each steps here. So that is all about the predictive analytics process. If I also attach here the fundamental data mining process, as we can see, actually the predictive analytics lies inside the data mining process. We have so big story under the data mining. We have predictive, we have supervised and unsupervised, but we have the standard process that we can follow. If we look at the process that I've been explaining in the previous slide, it involves almost the same. The business understanding is where you define the requirement, and data understanding and data preparation is combined together, and you model and you evaluate and you also deploy. So it is also actually on the basis of this data mining process. So there's a lot of popular predictive modeling techniques that you can use if you want to run a predictive analytics project, which can be viewed as statistical models or machine learning models. whether your data is a time series data or a cross-sectional data. So it depends on which classifier is suitable for your kind of data. So if statistical model, there's a lot of model like linear regression, time series, ARIMA, SARIMA. But if you're dealing with, if you want to use a machine learning model, the basic one is decision tree, neural network. We have support vector machine, naive Bayes, and we have the ensemble models like random forest, gradient boosting, deep learning, or LSTM. So, and next is the final part is some tips for effective predictive modeling. I just like to share based on our experience. It is important to pay extra attention on the how you acquire your data, you sort the data, you clean the data, and prepare the relevant and enough data for analysis. This is very important because if you are acquiring a different data, it might not answer your business goal and business objective. So the second is you need to really understand the data. Don't straight away run the analysis before you look into the data tab and do the data audit and exploration. And be careful with the performance of classifier with imbalanced data types, because if you run the model with imbalanced data types, sometimes it will give you high accuracy, but it would lead to a low sensitivity, because fitting or producing a predictive model with imbalanced data would produce a bias in the performance, where it would bias in terms of the majority groups of data. So, and pay attention to overfit and overtest model, because sometimes some model might overfit. It might only memorize the data sets in the training data, but it perform very bad in the testing data or validation sets, because it cannot be generalized for the actual data. And finally, make sure the predictive modeling project address your real business challenges, because that's why the first step is very, very important, because it would lead to the final one. Okay, so these are some of the examples that we have been doing. We come up with a prediction model in health disease to predict dengue outbreak in Selangor using machine learning techniques. So this is one of example of using the some of the techniques that we have been applying. We're using support vector machine, decision tree as well. And in environmental health, we predict water quality classification. So in Kelantan River, using machine learning as well. So in tourism sector, we predict visitors to totally protected area in Sarawak using machine learning. So all the same process we have been doing. And also in educational data mining, we are using, we are predicting students' performance using supervised data mining. The predictive is actually the supervised learning. And also in education data mining, predicting the student dropout in higher institution. And last is in road accidents, we apply decision tree to model the non-fatal road accidents injury. And our ongoing project on one big predictive analytics project is now is developing the integrated intelligence early detection and warning system for dengue outbreak prediction. So this is ongoing, where we are following the same process. First steps is we access and explore the data. So then we work with the messy data. So here, actually, we are still in the process of collecting data. But before we do the data acquisition, we, of course, define the user requirement. Like we've been discussing with MOH, what are the important things, what are the things that MOH is, the aim from the expert from MOH. So they want to see, we want to predict the dengue outbreak. So we come up with this system, and we will acquire data, collecting data from using IoT as well, and also integrate the data from MOH, and we perform some data analytics and come up with predictive model, and we will integrate the analytics into a system, dengue dashboard, and we will monitor the data and produce this integrated intelligence system. So with that, I end my presentation for this sharing session. Thank you so much.
Thank you very much to Dr. Wan Fairos. That was a great presentation on the predictive analytics and how the process is actually, going on, okay, from the first step until the end. So I think there were a few takeaways that I can have for your based on your presentation just now. I think I can say here that predictive analytics is actually needed for all kinds of businesses. Okay, especially it will help or assist the management team to make a data-driven decision. Okay, that's the first thing. Okay, I got from your presentation just now. And I think the good things about predictive analytics also is where the management team also can use it for forecasting purposes, okay, where it can be done in order to predict the costs, such as the operating costs in the business, the sales volume, and so on. So it can be used in order to come up with a good strategies in future. All right, so let's move on, okay. Perhaps if you guys have any question, you can just type it in the chat box. So I will address to the speaker at the end of the session, okay? So let's move on to the next speaker. So our next speaker today is a lovely lady, okay, Dr. Syerina Azlin, Muhammad Nasir. So Dr. Syerina is a senior lecturer in Department of Computer Science, College of Computing, Informatics and Media, Universiti Teknologi Mara, Cawangan, Kelantan. And she's been with UiTM Kelantan since 2004. She's also a member of Business Datalytics Research Interest Group. Okay. She received her PhD in Information Technology from UiTM and completed her undergraduate studies from University of Salford, United Kingdom. She is also a member of Microsoft Certified Professional, IEEE Computer Society, International Association of Engineers, Certified Rapid Minor Analyst, and Certified Talent Data Integration. So her research interest is mainly in database technology, ontology construction and mapping, data mining, data analytics, text, and web mining. So without further ado, I would like to invite Dr. Syerina Azlin to present her presentation titled The Use of Text Mining in Analyzing Unstructured Data. So Dr. Syerina, the floor is yours.
Okay, thank you, Dr. Wan Marhaini. But before that, can you help me with the slides because I cannot share my slides using
Okay, can you
WebEx.
share?
Yeah, I already shared with you.
Oh, really? Okay.
Yeah.
Just give me
So
1 second.
sorry for that.
Sure. No worries. Just give me 1 second.
Okay, before I start, let me give a brief about what I'm going to share for today. So it's basically on using a text mining, okay, in analyzing unstructured data.
Do you
So
see
what
the slide?
yeah, this is the slide. Thank you,
All right.
Dr. Wan M.
Okay. No
Right.
worries.
Okay, so Bismillahirrahmanirrahim. So the title of my topic for today is the use of text mining in analyzing unstructured data. So next, you can see next slide.
Okay.
Yep. Okay, these are the outlines for my presentation. So basically, I'm going to start out with the introduction to text mining. Next slide. Sorry. Okay, right. So I think most of you might have heard about text mining. Okay, so basically, when we talk about text mining, it's actually how we analyze data, especially if data is in unstructured format. So sometimes the word of text mining and text analytics are used interchangeably, but both terms is actually describing a range of technologies that are being used to analyze and process semi-structured and unstructured text data. So what it will do, it will turn the unstructured data into structured data because unstructured data is actually a qualitative format. So when we want to perform analysis, we have to convert it into structured data, okay, for qualitative analysis. Right, so most of these text mining purposes, but normally it is used to reveal the frequency and commonality of strong words or n-grams across groups of documents. When we say n-grams, what does it mean? It means that some of the words, sometimes we need two words combined together to give meaning. For example, like air conditioner. If we single word, okay, air, it means different thing. Conditioner means different things. If it's combined together, it gives a different meanings. So that is how difficult when we're dealing with text, right? So, and then it can be used to cluster different documents based on textual similarities. Okay, you can cluster the text to similar features. We can use it to predict information based about the future text using standard statistical modeling and algorithms. Okay, next slide. Okay, I think the next slide is actually for me to explain about the text, the different types of text data. Right, the first one is actually the structured data. I think most of you are very familiar with the structured data, which is data having a defined data model, format, and structure. Can you click data one? Can you? Yeah, so this is an example, okay, of data, of structured data. You can find it in any databases, in Google Sheets, in Excel, and also in star rating. Right, next. All right, we have semi-structured data, okay, semi-unstructured data or semi-structured data. Okay, it's actually a textual data with an apparent pattern. Okay, this is also used to enable analysis. So you can find it in XML files, you can find it in emails. They have a meta text there. You can find it in tweets. Okay, also the next one is the unstructured data. Next. Unstructured data is actually data that has no inherent structure, okay, and it's usually stored as different types of files. So here, okay, if you can press next slide, I can show you examples of unstructured data types that you can find whether in text, in documents, or in any server, in websites, okay, or sensor data, images, video files, all these social media data, all these are considered as unstructured data types. So it's very clear, you can find it, all this data, okay, currently or now, if you're talking about big data analytics, where the use of, we can have all these types of data over the network, and it's growing drastically every day, because you can imagine, for example, like if you're using a social media, not only that you upload your posts, but also you upload your pictures, and sometimes you upload your images. That is one individual, one day. So imagine how many users of Facebook using it. Okay, so then the numbers of this data growing, okay, exponentially every day, every minute, every seconds. Next slide. So when we're dealing with before that, is it? Okay, yeah, thank you. Right. So to analyze this, we have to go through a text mining process. Right. There are several important transformations that must be made in order to to make sure that your data is ready before you can do a text mining process. So normally the data sources, it can come from any databases, okay, in a format of CSV. So if it's in a format of CSV, so it's okay, you can just do all the cleaning process. But let's say if you extract the data from a website, for example, like from social media, from articles online, or from a report online, so normally you need to extract this using a web scraper tools. So these web scraper tools, most of these social media platform, they also have the extension allow you to scrap from all these platform. So you can use that web scraper tools to download or to extract the data. So once you have the data, of course, you have to do a preliminary test formatting, because sometimes you need to convert the data into text format, okay, into text format. And sometimes you have to remove some of the columns that you are not required or does give no meanings in your analysis. So you have to do the preliminary formatting first, right? And then you have to perform the basic processing. The basic processing. This is the key, the main things when we talk about when we do the before we can do analysis. So when we talk about tokenization, I think what the basic idea is how we want to convert each let's say you extract one post from any social media, okay, one post, and this post contains, like, let's say 15 words, 15 words. So what you need to do is you have to convert it in every words into a token. In other words, if you have 15 words, okay, when you perform tokenization, it will become 15 token, right? Because from this token, what you are doing is you transform it into a structured data, into a structured data called token, right? And then you can perform stemming. Okay, what we mean by stemming is actually you want to find terms that share a common root word, a common root word, so that when you have a common root word, you can combine them because they mean exactly the same thing. So that is stemming. That is the process of stemming. And then when we talk about stop word removal, this is in text. We have like conjunction, joining words like and, since. So all these conjunction words, we have to remove them because it doesn't give any meanings as well. And sometimes you have articles like the, and, all these also have to be removed. So that is the process when we talk about stop word removal. Okay, can you press next? I'm going to show you some of the applications, okay, where you can use tools to help you to do this process. So we have like open source software that you can use, like RapidMiner, Weka, Orange, that can help you to do this analysis. And the one that I'm showing you here is actually using a RapidMiner. So this is a process when you do basic text pre-processing or processing, which consists of a very simple operator, which is click and drag. For those beginners, I think this is the tools that you can use before you can go for advanced one, where you use a programming language like Python or R to conduct more flexible analysis using the language. Right, next slide. Okay, then we have before that, slide before, yeah. And then we move on to the advanced analytics. So here is after you have cleaned all the data, then you can perform, okay, whatever analysis according to the objective of your research. So here I'm going to share you several of the techniques that you can use. Next slide. Right. Right, so the first one is actually predicting review rating using KNN. This is example of prediction, which is a supervised learning. So you imagine text mining is the textual data is very challenging. It's a very messy types of data. So after you clean them, okay, when you want to perform analysis, there's something that you have to look into as well. Because when you perform this analysis, for example, like prediction, right? So there's the challenges that you have to cater before that, because the nature of the data is actually if you have performed the cleaning, okay, you will have every token or every words that you have extracted, you have performed the pre-processing, it become a variables, a parameter, okay, in your analysis. Okay, it becomes a new variable, a new parameters. So just imagine if you have like thousands of words, yeah, you have thousands of parameters. Okay, because you convert into token, because you want to analyze each of these words. So this is very high number of features. Okay, so that is challenges. You have normally when you do like structured data, okay, you will have the numbers of the parameters or variables, okay, is smaller than the numbers of the documents or the reports that you have. But for text analysis, is the other way around. Okay, so the number of parameters or variables is bigger or compared to the number of the documents that you have. So that is the challenges. Okay, and the second thing, because of that nature, you have very high sparsity, which means that each of the new tokens that you created, then you some of the data when you process, it will have zero values. Okay, because all the words, which means the only documents that contain that particular token, then you have value. Okay, for the rest, it will be 0. So this is high sparsity. What does it mean by high sparsity? Yeah? So sometimes the majority of the cells are either not filled or 0, contain 0 values. So for this, when we want to do prediction, okay, suitable algorithms for that is normally we use naive Bayes, support vector machines, and KNN. So example here I show you is just example of using predicting review rating using KNN. Okay, right. The second one is text clustering. So text clustering is a task of grouping a set of unlabeled. So this is for unsupervised learning, right? You have no idea the number of categories that you will come out, okay, after you perform the clustering. So normally what you will do in such a way that you want to cluster in such a way that the text in the same cluster are more similar to the one to those in other clusters. So this is used in order to determine a group among unlabeled data. So you use text clustering, okay? And then we have sentiment analysis. I think most of you some okay might have heard about sentiment analysis. So basically, okay, you can say sentiment analysis, you can say opinion mining. Okay, normally it's involve natural language processing where you identify the emotional tone behind a body of text. Okay, so this is popular way most of the organizations use this in order to categorize opinions about a product, okay, about a service or about an idea. Right, next slide. So after you have performed all this analysis, normally we visualize it. Next slide, Dr. Wan M. Right, so visualization, next slide. So this I show you some of examples of visualization. For example, the one that I've mentioned earlier, okay, we do prediction for rating. So when you predict the rating, for example, like hotel review. So normally you have rating, you ask your customer to rate, okay, your hotels, review your hotel reviews. So it give rating. So based on that rating, also based on their comment on each of that, then you can use that. Okay, you can use that to do a prediction. So that if there's a new post from customers, but they did not give any rating, you can use the model that you have done earlier, and you can predict whether the post that has been by the post made by the customers, okay, whether you can it's a low rating or high rating. Okay, you can use that as well, right? And for clustering, for example, in this example, this is based on our RIG works. So you can also cluster jobs according to a location. So based on the clustering text, you can see, for example, it's too small because there's a lot of parameters there. So you can see that based on the jobs being offered and the location, you can see that the one in green and blue, green and black. So it's actually Kuala Lumpur and Selangor during the pandemic. This is case during the pandemic, job offers. So you can see that Kuala Lumpur and Selangor, they offer a lot of jobs during a pandemic. Okay, during a pandemic. Okay? Then you see what kind of jobs they're being offered is being listed there. So this is the other way of doing, we can use text clustering as well. Yeah? Right, and if you can see the next one is sentiment, that is the visualization, visualize it, okay? So those in, if you can see the priority, okay, value 1, that is positive. If negative 1 is negative. If 0 means neutral. So here you can see that based on this diagram, you can see that it has a positive reviews. Okay, next. Right, so as a summary, basically, so you can use text mining. Okay, it's either you can use a text classification based on content, which means that you can take examples like articles, okay, from articles online. Okay, you can categorize based on the meta text predefined. You have already predefined categories. They based on this text mining. You can categorize it based on which this article belongs to which category. So that's one example you can use. So sentiment analysis and reviews, like I mentioned earlier, you can do that. Or you can also use for authorship attribution based on vocabulary and writing style, where you can mine, okay, the articles or report, okay, and you can determine who are the author based on the vocabulary and the writing styles of the author. Okay, that is also can be used. And you can also use, like I mentioned earlier, unsupervised. Basically, if you look quite similar to text classification, the difference is here, it is unlabeled. You don't know the number of clusters that you will get. That's why you use text clustering. Okay, and like I mentioned earlier, text the sources, data sources, it can come from many sources. Okay, like I mentioned, your customer support, textual technical support, okay, emails, advertising, human resources and competitors, and all this from also websites. Again, next slide. Okay, so also here I'm sharing you some of the text mining applications in several domains. So it looks that we have text mining, we don't know what to do, but I hope by going through this, you can see that there's a lot of applications of text mining in many domains that you can use. For example, in government itself, you can identify fraud based on the tender, based on report. All this can be done as well. So even in retail, if you want to find manage the brand on social media, you can also do that. You want to see whether or not the user accept your brand or not. Okay, they have positive or negative, and you can see what are the words being used. Okay, and you can use that words to become the motto of the company, become parts of the brand. This is some of the things that you can use using a text mining, right? So next slide. I also share you. Okay, so this is some of the works that we have done, okay, in text mining. Our teams have done, okay, for text mining. So with that, I think I end my presentation. Thank you.
Well done. Thank you very much, Dr. Syerina, for the insightful sharing. So no one could imagine that, from all many response in the social media, you can turn it to become a data, okay, to become a very structured data from unstructured data. But, you need to have a very good analysis in order to convert from the unstructured one to become a structured one, okay? So I think the takeaways that I can get from your presentation just now, basically for most of the businesses who do not have a structured data, but at the same time they have social media, basically they can use the responses from the social media as in the form of the unstructured data to turn into a structured data, but they need to know the right techniques of doing that. And tech clustering, sentiment analysis, this is among some of the techniques that use in analyzing the unstructured data, specifically in the text mining. Okay, so let's take a look on the questions in the chat box. Okay. Yeah, we have numbers of questions here. So probably I'm going to take the first question here. Okay, that's from Dr. Azlin. So is it predictive analysis can identify the length of product or project being stay in the market? It is important to the company to identify the discontinuation of product or project that the company can strategize to improve it or create a new product project in the future. So I believe this one will go to Dr. Fairos. Okay, Dr. Fairos, you would like to respond to that?
Okay, Assalamualaikum. Thank you to Dr. Azlin for the questions. The questions is about, can predictive analytics identify the length of product or project being stay in the market? The answer is yes. It can be used to identify the length of stay or the characteristics of the product, whether it is stay in the market if and only if the data on the availability of that particular product can be measured. Availability of that particular product in the market can be measured. For example, if you want to predict the potential customer churn, you might not have a data of exactly measure churn, loyal churn. This is a loyal customer, this is a churn customer, but you might have a data where it gives you the date where the customer is no longer using the product. See, so from the data set, the date where the last date of the customer used the product can be transformed into a new variables measuring whether it is churn or loyal customer. Same goes to this particular questions for to identify the length of the product. So if you have that particular data measured, can be measured, and it is available, you can we can use the data, we can train the data, we can see, we can look at the pattern, the characteristics of that particular similar product that stay in the market, and the group of the other product that is the same product that is no longer in the market. So we can use that to predict the incoming new data set, whether with this similar characteristics, we can predict that it will be a high chance that it will be no longer in the market, something like that.
Okay, all right. So I hope it's answered the questions. Oh, hold on, give me 1 second. Okay, the second question, I think it's from Dr. Nasir. Just now you did mention about overlifting problem. Can you share what it means by the overlifting problem, how it happens, and how to avoid it? So yeah.
Okay, all right. Overfitting problem is a problem where it happens when we fit a predictive model, and the model that we fit, normally when we fit the predictive model, we partition the data into training and testing set. We are not going to use all the data set and train and fit the model. We normally would partition the data into training and testing. So the training set is used to run the model, okay, to develop the model. And normally we expect that the model that we develop using the training sets, it perform good as when we apply this data for the testing set. But sometimes it may happen where the data, that the model that we decide that we predict, that we develop using the training data set, perform good using the training data set, but it performed bad in the testing sets or validation set when we apply the same model to the other portion of data, which is the testing set. So the issues is that the model sometimes overfit. It sometimes generally memorizing the pattern of the data, the trend in the training data set, up to when in the testing data set, although the fluctuations or the trend or the characteristics in the testing sets is differ from the training set, therefore the model would is only memorizing the pattern in the training set. So when it happens, it will give you a very big error between the actual and the predicted. For example, the accuracy model in the training set that you get from the best model will give, mostly the error is small in the training, but sometimes you will see the error in the validation set is very big. So that's why a situation of overfit is happened. So we need to, overcome this problem. We need to check, is there any overfit issues happen in this modeling process? Because what we want is actually, if you get small error in the training set, we should also get small error in the testing set or validation set, so that we can conclude that this model is good. So there is no overfitting. So there's a lot of ways that we can overcome the overfitting. You can use cross validation. You can also apply a different models like random forest. You can do cross validation instead of simple data partitioning. So you can use cross validation sets techniques. So that is about overfitting.
Okay, all right. Thank you, Dr. Fairos. Okay, I think the next question is to Dr. Syerina. So are there any differences between text mining with other forms of data science, such as image or speech recognition?
Okay, I think I should answer that, right?
Yep.
Okay,
yep.
of course. If we are directly comparing with image and speech recognition, of course, there's a difference about that. But for this like image recognition and speech recognition, there's another way of converting these types of data into textual data. So it requires another software to help to convert those speech recognition or image recognition into a textual data. So once you have converted that into textual data, of course you can use the text mining to perform analysis, and of course the type of analysis depending on what you want to what are things that you want to get from that, right? So for sometimes for example, like image, it requires like um, um, optical recognition, character recognition, or sometimes with the image it comes with the explanation of the words to describe about that. So that elements is embedded or being used to perform text mining. Okay, and of course speech recognition, it needs a different, if you're talking about speech recognition in terms of the voice, okay, to analyze the voice, okay, the voice data, of course, it requires a different, it's not text mining, but a different analysis. But if you convert the speech into text, then you can use the text to perform the text mining. Yeah.
Okay.
Should it answer that?
All right. Okay. Thank you, Dr. Syerina. I have one question to Dr. Erin, Dr. Syerina.
Yeah.
So you mentioned about just now regarding the, the business people, okay, when they want to improve their strategies, and they don't have any data, they don't have what you call that, a solid data, a structured data, okay, to use to analyze, for their strategies improvement, but majority of the businesses, it is compulsory for them to have a social media. Okay, they will have a social media account. Okay, and they will use it for the marketing purposes. Okay, in order to get the response from the buyers, from the customers. How you can advise or how you can suggest for them, those who does not have structured data but they have social media, for them to improve their strategies, and what kind of strategies that they can improvise by using unstructured data?
Okay, I think when we talk about the social media data, okay, there's advantages and disadvantages. But for business people, they have to think this is a advantages for them, because actually you can use it to strengthen your companies. For example, if you want to compare your competitors with yourself, for example, you cannot have a direct answers for that. So what you can do is you can one of the way is you can how you can say spy on your competitors. For example, I'm using the word spies because most of the comment posted by the customers from your competitors, you can use it, you can analyze it, and then you can see what are the strengths or what are the things that is preferred, okay, by the customers, by your competitors customers, okay, and you use the data to see and look back, observe back whether you have that elements or not, and you can even turn it into finding factors that influence that brand, for example, right?
Yeah.
Only by looking at, for example, from CSR report, for example, or sorry, from a company report. So
Yep.
you can annual report. So you can use that to see what are the factors that for these successful companies by just analyzing those successful annual report. Then you can see you can determine the factors using this text mining. That is another way. And I think for your customers as well, okay, sometimes you can detect the element of negativity from your customers. Yeah? So when you have this text mining, when you of course when you are doing business online, you must have people who monitor your business online as well. So when it detects all this negative influence, so automatically your team can immediately try to overcome it, okay, to reduce, because it relates to the brand as well, right? I think that is some of the things that I think I can share with you regarding this, the beauty of text mining for business people.
All right. Thank you, Dr. Erin. Interesting. Okay, interesting answer. Okay, I think maybe we can take the last questions from the chat box. Or if you have any question you would like to ask directly to our speakers today, you can just unmute your mic, okay? But I will take the last one from the chat box here. I think this one's from Dr. Norihan. Assalamualaikum warahmatullahi wabarakatuh. How can predictive analytics address insufficient data for making prediction? Okay, I think this one should go to Dr. Fairos lah. Okay, all right.
Okay,
Silakan.
all right. How can predictive analytics address insufficient data for making prediction? Yeah, to answer this question, it goes back to the maturity, data maturity of that particular organization. So, yes, if a company, if we measure the company data maturity, where the data maturity is the measurement where the extent of to which the organization is utilizing their data, the availability of their data, how they utilize the data to which level of utilization that they are using their data, and the availability of the data. If they achieve high level of data maturity, normally they would deeply engage the data and embed their data in the organization. So if that is the case, then it can solve issues of the insufficient data. Okay, but if the organization is not, really matured in this availability of the data, utilizing the data, the organization data, then what we can do in predictive analytics is you can, as an analyst, you can consider other data, not only in a structured data. You can also look at the unstructured data and consider that particular data to be recode and transform it into structured, and you can use it in the predictive analytics model. Besides, from looking at this unstructured data as well, you can also go back to the model parsimony. You can consider a simple model. Do not use a complex model. Sometimes a simple model is a better model. Or even you can also combine few simple learners to obtain a better model. So those are the things that you can consider in handling the insufficient data for predictive analytics.
Okay. All right. Thank you, Dr. Fairos. So I think we are past 11 already. So we have come to the end of the session. But before that, don't forget to fill up your attendance. The link for the attendance will be shared by the Secretariat after this. But before we end the session, I think I would like to ask all of us here to turn on your camera so that we can have a photo taking session for this webinar. Mungkin saya perlukan bantuan Secretariat lah untuk take the photo. So maybe you can turn on all the camera. Okay, so we have around 46. Okay. Boleh turn on camera ya. Okay. Alright, so tak apa, kita ambil je mana yang turn on camera lah. Okay. Okay, tak apa. Alright. Okay. 1, 2, 3. Okay. One more. Freestyle. 1, 2, 3. Okay. All right. So, ladies and gentlemen, we have come to the end of the session. So I would like to thank both speakers, Associate Professor Dr. Wan Fairos and Dr. Syerina Azlin, for the insightful and great sharing. We actually have many new information today, okay? And thanks also to the active participation from the attendees throughout this session, Okay, we have numbers of questions being asked just now, and we hope all of you found this webinar beneficial. So before my last word, I would like to read one of the quotes from Imam Al-Ghazali. Knowledge without action is wastefulness, and action without knowledge is foolishness. So dengan perkongsian ilmu pada pagi ini, I would say that it can be used as our guidance, okay, for our wise and productive future action, insyaAllah. So semoga Jumaat barakah untuk kita semua. Thank you everyone. Stay safe, insyaAllah. Until we meet again. Assalamualaikum and bye-bye.
Terima kasih. Assalamualaikum.
Thank you semua.
Thank
Assalamualaikum.
you.
Bye. Thank you.
Thank you, speakers. Excellent.
Thank you.